Idea, thank you. I'm recording right now. It's the law of total probability is something related to conditional probability and application of multiplication rule. Okay, if I want to find out the probability of certain events, how can I find it? There will be three different partitions. Okay, there will be three different bags, three different classes, three different categories. Okay, and there will be a subset of that category here, another subset of a category in another category, another subset in another category. Okay, it's like probability of A given B1 times B1. Let's say I have bag 1, choosing the probability of bag 1, and I'm gonna find out choosing the probability of bag 1 is given, and I want to find out, let's say, the marble is green. Okay, we will have such examples together. Okay, now I'm going to tell you how to implement these formulations. Then I'm sure you're going to remember what those things were. Okay, so let us start with this example right now. Can you see the example? I hope you can read it. Suppose there are two bags in a box, okay, which contain the following marbles. Bag 1, 7 red marbles, 3 green marbles. Marble means bilye. Bag 2, 2 red marbles, and 8 green marbles, okay? If we randomly select one of the bags, there are two bags, okay? There are two bags. There is one bag here, there is another bag here, 7 red and 3 green, and there will be 2 red and 8 green here. And then I'm going to randomly select bag 1 or bag 2. Okay, bag 1, bag 2. What's the probability that it's a green marble? Okay, this is how I will approach to this problem. First, I want you to tell me what's the probability of choosing a green marble when I choose the first bag. It is like 3 greens out of 10 marbles, right? There are 10 marbles here. There are 10 marbles here. And 3 out of 10 marbles is green in bag 1. What's the probability of obtaining green when I choose bag 2? It is gonna be 8 over 10, right? 8 greens out of 10 marbles, it's going to be 0.8. Now it's time for me to find out the probability of green. Okay, how do I find it? Let us implement this formulation. Probability of green when I know that it's coming from the first bag and then choosing the probability of first bag, plus probability of green when I know that it is coming from the second bag, and I will write the probability of the second bag. Is that clear, guys, how I write this? Because we are going to use this in the next part of the class. It's like about Bayes' theorem, and we are going to use this finding the total probability. Okay, is that clear? Any questions here at this point? So what should I do? The next step is I'm going to put this here, 0.3 times this. What is the probability of obtaining the first bag? There are two bags. One of them is 1 over 2, right? 1 over 2 plus, what's the probability of obtaining the green when B2 is given? It's 0.8. This is also 1 over 2. 0.8 times 1 over 2. Right? Finally, it's going to be 0.15 plus 0.40, and it's going to be 0.55. Probability of green when I have this situation. Any questions here? It's an easy question about law of total probability. So if I have one probability here, another probability in one category, bag, or one class, okay, I can change the question like there are 2 classrooms, okay, there are 2 classrooms, and in one classroom there are let's say 7 female and 3 male students. In another classroom there are 2 female and 8 male students. And what's the probability of obtaining male student when I randomly select one of the classrooms? Okay, there are many different examples that you can do like that. Okay, is that clear? Any questions regarding this question, exercise? Let me move to another one. Now I want you to read the question. I'm going to read it out loud and I want you to solve it and write on chat. Company A supplies 80% of parts for a car shop and only 1% of their parts turn out to be defective, arızalı. Company B supplies the remaining 20% of parts for the car shop and 3% of their parts turn out to be defective. If a customer randomly purchases a part from the car shop, what is the probability that it will be defective? Okay. Now you have 2 minutes to solve the question and I want you to write on chat. Thank you. You always please warn me. The probability of obtaining a part from company A is 0.8, it's given here. The probability of obtaining a part from company B is 20%, 0.2. Okay, this is 80%, and this is 20%. What's the probability of obtaining a defective part when it is known that it's coming from company A? Only 1% of their parts turn out to be defective. So I know that it's coming from company A and it is defective, 0.01. That means 1%. The probability of obtaining a part which is defective when it comes from company B is 3%, 0.03, and it is 3%. And then finally, I will do this calculation, probability of defective, and then probability of defective given A. What is this? Probability of defective given A, it is 0.01. What is probability of A, the part coming from company A, it is 0.8. This is 0.03, and this is 0.2, right? So I'm gonna find out probability of defective is gonna be 0.01 times 0.8 plus 0.03 times 0.2, which is gonna be equal to 0.008 plus 0.006, which is 0.014, which is 1.4%. Is this clear, guys? Did anyone? Yes.
I don't understand the PDA part because the question says that only 1% of their parts turn out to be defective. So
yes.
Should we calculate the 80% of the parts of the hocam yani oraya Türkçe söyleyeyim. %80'in %1'ini almamız gerekmiyor mu? Toplam yüzdeden.
Aslında öyle yaptık bak. It is like out of 80%, 1% is defective if it comes from company A. Out of 20%, 3% is coming from part B, company B. So I have to add them up, right? I don't know whether it's coming from company A or company B. So I have to add those defective percentages together. Okay, I did that actually here.
Okay, I understand.
So this is like defective part coming from A. This is defective part coming from B. We can also do this, right, arkadaşlar? It is like a part, like 80% coming from A, 20% coming from B, and it's going to be defective in 1%. It's going to be non-defective in 99%. It's going to be defective in 3%. It's not going to be defective in 97%, right? So this is a tree kind of solution, okay? And then these are the defective probabilities, right? These are defective probabilities. How do I find those defective probabilities? It is like 0.8 times this plus 0.2 times 0.3. This is what we have done here. Okay, you may use this kind of an approach. Actually, they are the same thing. You may also come up with a tree diagram, let's say. Okay, is that clear, guys? How I come up with the tree? Like the part, this is my part, and 80% of the case, the part is coming from company A. 20% of the case, the part is coming from company B. And if it comes from company A, 1%, in 1% probability, it's going to be defective. And here, 3% probability, it's going to be defective. So what is the probability of obtaining a defective part? It's going to be 0.8 times 0.01, 0.2 times 0.03. Any questions? So I may have tree diagrams or solution for that. Can you tell me how I should come up with a tree diagram here? There will be bag 1, bag 2, and then there will be red and green, red and green, right? So if I come here and write, what's the probability of obtaining the first bag? 0.5. What's the probability of obtaining the second bag? 0.5. What's the probability of obtaining red marble when I know that it's coming from bag 1? It is 7. 0.7. Green bag, from bag 1, green, 0.3. This is 0.2, 0.8. It's coming from 2 and 8, right? So what is the problem asking? Green marbles. So I should focus on these. How can I find green marbles? 0.5 times 0.3. 0.5 times 0.3. 0.5 times 0.8. 0.5 times 0.8, which is going to be 0.55. Okay, I try to solve from a formulation point of view, like this one, and also with a tree point of view, which is the same thing, but it may be visual. If you are more comfortable with the tree methodology, you may choose to use this tree diagram solution. Okay. Anybody has any questions, guys, at this point in time? So let's move on to the third question, and I want you to mainly focus on the part A. You have 2 minutes to solve the questions. To turn on the camera, the recording. Everybody is okay with that, guys? So there are 2 regular coins and 1 fake coin. Regular coin means I have heads and tails with the same probability, which is 1/2. Regular coin, heads and tails with the same probability, 1/2. What's the probability of obtaining heads when it's fake? It is 1, only heads. Okay, and I solved it with 2 different approaches. One of them is a tree approach, tree diagram approach. It's going to be like regular coin and fake coin. What's the probability of obtaining a regular coin? There are 2 regular coins out of 3 coins. It's like 2/3. What's the probability of obtaining a fake coin? It's 1/3. And when I have a regular coin, what's the probability of obtaining heads? It's 1/2. What's the probability of obtaining heads when it's a fake coin? It is 1. So what do I have after? I'm trying to find out these H, okay? Total law. Law of total probability. This is like total probability. How do I find it? I go with this tree, with this branch, okay? So it's going to be this branch, 2 over 3 times 1 over 2. Another branch, if it is fake, should go with this line. It's 1 over 3 times 1. So then totally, it's like 2 over 3. Okay? So if I go to the next way of doing it, the second way of doing it, I'm after probability of heads. And if you remember, that was my solution. That was my formulation for obtaining total law, total probability. What's the probability of obtaining heads when it is a regular coin times choosing a regular coin, probability of choosing a regular coin, probability of obtaining heads when it is a fake coin times the probability of obtaining a fake coin. And the same thing, 1 over 2 times 2 over 3 plus 1 times 1 over 3, and the final result is 2 over 3. Is that clear, guys? At this point, do you have any questions? Okay. Okay, let me move on to the next topic then. Okay, we will use this concept, total law of total probability, in the coming parts of the class, and I will give a break. Let us talk about this condition probability, then I will give a break in 3 minutes. Okay, it will be a 10-minute break. So we talked about conditional probability before, and you had a quiz this morning. What does it mean? What's the probability of obtaining A given that event B has occurred? So it is like, I know that it is B has occurred. What's the probability of obtaining heads? So I am trying to find out the probability of obtaining A and B. This is AND, probability of obtaining A and B. Okay, A and B should occur together under the condition that probability A, probability like B event has occurred. Okay, so we are finding out the probability out of the given probability. Okay, that's what we did in the previous examples. So if you go to the Bayes theorem, it is a kind of, it uses the law of probability, conditional probability, and law of total probability, but it is a different way of saying things. Okay, like now I say probability of A given B is equal to probability of B given A times probability of A divided by probability of B. If you think about this, probability of A given B is equal to probability of A and B divided by probability of B. Probability of B given A is equal to probability of A and B divided by probability of A. This B given will be here. This A will be here, okay? The given part will be down, will be the denominator. Given part will be the denominator. What's the numerator? It is gonna be the common thing, common event, or an intersection of events A and B. Okay, is this clear, guys? So if you think about this, if I write probability of A given B and probability of B given A, what's the common thing? It is this common, right? I'm gonna write this probability of A given A and B is gonna be probability of B times this, right? Probability of A given B times probability of B. And also, same thing is equal to probability of B given A times probability of A. Do you understand the logic here? I'm using the same common factor here, and I say now they are the same thing. PA given B times PB, PB given A times PA, so they are equal to the same thing. Can you see that I'm going from this, like, can you go from this to this thing? I think you can go from this formulation, right? You can go from this and then find out this, right? Probability of A given B is going to be equal to this divided by, you can take this down and obtain the same Bayes' formulation. I know probability of B given A, and I would like to find out probability of A given B. So it's a kind of inversion of conditional probabilities. I know the probability of obtaining probability of B given A, and I would like to find out probability of A given B. Okay, is this clear, guys? So that's the trick. Let me talk about the formulation once again. I know this, and I would like to find out the other way around. Again, you see this A is down here. I'm going to multiply with this thing next to it, and this B will be always again down. Okay, because A given B is going to be over B event. Like, let me write again. Probability of A given B. I want to know this. When B is given, I want to find out the probability of A, and I know the probability of obtaining B event given that A event has occurred, times, you see this, after this thing, I will have this A here, this A divided by probability of B. Okay, and this given thing will be down. Okay, we will use this formulation in the next part of our discussions today, and it will be mainly about, it's called Bayes' theorem. Okay, Bayes is a mathematician, and he came up with many ideas about probability and statistics. So we will be talking about Bayes' theorem as we go further, and we will use the same two regular coins and one fake coin example: heads, tails, heads, tails, and heads. Okay, and then now I'm going to ask you. You can pick a coin at random and toss it and get heads. What's the probability that it is the two-headed coin? Now I know that I obtained heads, and I want to find out it's coming from the fake coin. Okay, let's have a break at this point. After the break, we will continue with this exercise, and then we will use the concept of Bayes' theorem, use this formulation, okay? Find out PA, PB, and PB given A, and then from that we will compute probability of A given B, okay? Hope to see you in 10 minutes. We will meet at 9:55, inshallah.
Hocam, we couldn't hear you.
So Bayes' theorem was about finding the probability, conditional probability, by knowing the inverted version of the probability, right? A given B is, we want to find out A given B, and we know a probability of B given A. So how can I go from one given or conditional probability to another conditional probability, okay? So this is the basic idea behind Bayes' theorem. So what is being asked here? I have two coins, regular coins, and one fake coin. Regular coins have heads and tails, but fake coin has only heads. We pick a coin at random and toss it and get heads. Okay, we know that it is heads. What's the probability of that it is two-headed coin? How can I write the conditional probability? What is known, what is not known? Arkadaşlar, what is known? What is known? It is coming. Exactly, it is heads, right? I should write it here. Known is here, known. What is not known, what is the thing that we want to find out? That it is from the fake coin, okay? Probability of fake given heads. Probability of fake given that it is heads. Is that clear how I write this, guys? Yes, I hope so. Then I will go to the formulation here, given here. This is A given B. Now B given A. I'm gonna write probability of heads given F times probability of F. You see, this F is gonna be here, divided by this H is gonna be here. Is this clear, guys, how I write Bayes' formulation? Probability of F given H is my question. Probability of H given F is the other way around, the inverted version of it. And do we know that this? Do we know this probability of H given F? What did we find in the previous question?
Hocam.
What did we found? What did we find until now? What are the things that we know? Sorry, let me put it that way. Do we know probability of heads given F? If it is a fake coin, I am gonna have heads for sure, right? The probability is gonna be 1. What's the probability of F? Probability of obtaining a fake coin is 1/3. Probability of heads, this is something we found here in my previous exercise, and we used total law of probability. Probability of heads is 2/3. I'm going to write here 2/3. And finally, I'm going to write P F given H is going to be equal to 1 times, this is 1, this part is 1, here it is 1, times 1/3, divided by 2/3, which is going to be equal to 1/3 times 3/2 is going to be equal to 1/2.
Hocam,
So,
can I ask them?
Sure, please.
Hocam, can you tell again how we find the 2/3 on the probability of heads?
Sure. It was the condition total law of probability. Here we found probability of heads by either using a tree diagram or the total law of total probability formulation. How do I do it? If I choose a regular coin, what's the probability of obtaining heads? 1/2. It's a regular coin. I'm flipping a coin and heads is 1/2, right? Probability. What's the probability of choosing the regular coin? There are 2 regular coins and 1 fake coin. So the probability of obtaining a regular coin is 2/3. Plus, it is not over yet, right? We don't, can we have heads when it's a fake coin? Yes. Can we have heads when it's a regular coin? Yes. I have to consider both situations, both conditions in order to find out the heads, probability of heads. That's why it's called law of total probability. Okay, it's not only one probability coming from the regular coin, but there is also another probability coming from the fake coin. So that's why 1 over 2 times 2 over 3 time plus 1, like obtaining heads when it's a fake coin, is 1, right? There is no other option. There are 2 heads. There are 2-headed coins. So all of the time it's like 1. What's the probability of obtaining fake coin? It's 1 over 3. So that's why 1 over 2 times 2 over 3 plus 1 times 1 over 3, it's going to be 2 over 3. Is this clear?
Clear, hocam, I got it. Thanks.
Clear. Thank you. You're welcome. So, everybody got the idea here? Did you understand? What did I do here, guys? I know that I got heads, but I want to know, is it a 2-headed coin that caused this heads? Yes or no? Or what's the probability? How can I do it? First, by reading the question, I want you to understand what's this? I want you to understand this, what is being asked? What kind of a conditional probability is being asked? Okay, that's the main problem that many students might have. You have to write this. How do I write it? Probability that it is, probability that it is 2-headed. So it should come from a fake coin. But what do I know? I know that it is heads. So known is going to be here. What's the probability question is going to be here. Okay. And then if I have this, then what should I do? I'm going to apply Bayes' theorem. Like A given B equals B given A times probability of A divided by probability of B. So this B is going to be here. This A is going to be here. And then probability of B given A. So what is my probability of B given A here? It is, this thing is going to be here. This thing is going to be here. This is probability of H given F. Times probability of F. So this is A. Divided by probability of H, obtaining heads, right? Because I know heads has come, and I want to know whether what's the probability of obtaining that heads from a fake coin. Okay, then the second approach. So the first step is to come up with, this is my first approach. Okay, first step, let's say. The second step is going to be writing the probabilities which are related to this. Okay, do I know probability of heads given fake? If it's a fake coin, the probability of heads is 1. It's always heads. What's the probability of obtaining heads of a fake coin? 1 over 3. We know it from the problem. What's the probability of heads? I know it from law of total probability. I just solved it. 2 over 3. Then I'm going to plug in those values. 1, here it is 1. It is 1 over 3. This is 2 over 3. 1 times 1 over 3 divided by 2 over 3. It's going to be equal to 1 over 2. Is that clear, my friends? Is this clear about Bayes' theorem? Any questions? So let me go to the next question. And now I will give you, let's do this one again together. Then I will ask you a more difficult question. So let us do that. I am tossing a coin 5 times. Let H1 event be first toss is heads. And HA event is all 5 tosses are heads. Okay? First toss is heads. The other one is all 5 tosses are heads. Now I want to tell you, I want you to tell me what's the probability of obtaining H1 given HA? What is it in words, sentences? What's the probability of obtaining first toss being heads when I know that, or given that all tosses are heads? What's the probability of H1 given HA? What's the probability of H1 given HA? No answers yet? Nobody understood what's being asked? Exactly. I got 3 answers so far. 4 answers. 5. So it is 1, right? Why? Because I know that all tosses are heads. This is known for this question. If all tosses are heads, what's the probability of obtaining first toss being heads? 1, right? If I know that all of them are heads, what's the probability of obtaining the first as heads? 1, right? Everybody got the idea here? Arkadaşlar. So, what is that? This problem is, it is known that all 5 tosses are heads. What is the probability? What is the probability of obtaining the first toss as heads? That is the sentence-wise, this is the question, okay? It is known that all 5 tosses are heads. What's the probability of obtaining the first toss as heads? So 5 tosses are heads. 5, H, 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 H. What's the probability of obtaining heads as my first toss? 1. Now let's look at from the other side. It is known that the first toss is heads. What is the probability of obtaining all tosses heads? So that is this probability. I know that the first toss is heads. What's the probability of obtaining all tosses being heads? Let's do it here. Probability of HA given H1. Okay. So what is the probability of obtaining this conditional probability? HA and H1 divided by a probability of H1. This is conditional probability, right? What is the probability of obtaining HA and H1? This is AND. So obtaining the first toss being heads and all tosses are heads. What is the common thing here? Arkadaşlar. Hatice, Özlem, Furkan, 116, Abdullah. Some of you said 116.
Hocam,
Why is it? Yes.
Heads in the first toss, maybe. This is the common for the both of them.
So, I couldn't understand your question. Did you ask a question or comment? Which one?
Comment, hocam.
Comment. Sorry, let me change the power source. Okay. So what's the probability of HA and H1? First toss is heads and all heads. What's the probability of that? What's the probability of obtaining H1? First tosses. First toss being heads. What's the probability of that, arkadaşlar? Can you tell me? What's the probability of this? Probability of obtaining H1? 1/2, right? First toss, either tails or heads. So I'm asking what's the probability of obtaining the first toss as heads? So it is 1/2. What's the probability of obtaining the first toss being heads and all tosses are heads? What is it? It's going to be 1/32, right? And finally, 1/32 times 2 over 1. This goes up, and then it's going to be 1 over 16. Why is it 1 over 32? Can you tell me why is it 1 over 32? Because this being first toss being heads and all tosses being heads are only this option, right? H, 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 H. So HA and H1 is H, 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 H. All tosses should be heads, and first toss is also H. So what's the probability of obtaining this out of 5 tosses of a coin? How many different options do I have when I toss a coin 5 times? 2 to the power 5, right? Which is 32. Because each case it is heads or tails, heads or tails. So two options, heads or tails, 2 options, heads or tails, 2 options. So there are 5 such situations, and then it's like 2 to the power 5, which is 32. This is 1 out of 32. And the conditional probability is going to be equal to 1 over 32 divided by 1 over 2. It's going to be 1 over 60. Is that clear, my friends? HA given H1. Now I want you to tell me, how can I go from H1, HA and obtain the Bayes' formulation? Okay, this is Bayes' theorem. So I'm trying to find out H1, probability of H1 given HA. And I need to use probability of HA given H1 times probability of H1 divided by probability of HA. What is probability of HA given H1? HA given H1, we found it, right? 1 over 16. What's the probability of obtaining H1? First toss being heads, 1 over 2. Divided by all tosses being heads is 1 over 32. So it's going to be 1 over 32 times 32 over 1, which is 1. This is something we found being equal to 1, right? So this is equal to 1. So I proved that Bayes' theorem is correct for this question. I can do the same thing. HA given H1 is going to be probability of H1 given HA times probability of HA divided by probability of H1. So what is probability of H1 given HA? It is 1. It is given 1 times probability of HA. What is probability of HA? All tosses being equal to heads. Probability of 1 over 2. It's going to be equal to 1 over 32 times 2, which is 1 over 16. So we proved that I can use, let me show it here, I can use one conditional probability to find out the other conditional probability. That is called Bayes' theorem. Okay, using one conditional probability to find out the other conditional probability is used for Bayes' theorem. Is this clear, guys? Let me ask you this question, and it is your time. Like, you have 2 minutes to solve this question right now. What is the probability of a car coming from factory A? What is the probability of a car coming from factory A? It is given 0.5 or 50%. Probability of B being equal to 0.3. Probability of C being equal to 0.2. Okay, so this is something that we can write in the first step by obtaining the information from these sentences. Okay, and next, what is this, like 30% of the cars produced in factory A are white. Okay, what do I know? Probability of obtaining a white car given that it's coming from factory A. Probability of obtaining a white car given that it's coming from factory B. Probability of obtaining a white car coming from company C or factory C is this. What is the probability of obtaining a white car when I know that it's coming from factory A? It is 30%, 0.3. What's the probability of obtaining a white car when I know that it's coming from factory B? 40%. And 25% when it is from factory C. Okay, these are all the things that I know from my question. So what's the thing that is being asked? If a company is selected at random, I'm going to choose either factory A or B or C, and I want to find out the probability of obtaining a white car. Okay, arkadaşlar, many times my friends, the students have hard time in understanding the question itself. This question is easy to understand, but there are some tricky questions in which you have to understand all words and you have to put the words into numbers like that. Okay, that may be a problem for some people. Please make sure you practice enough to be able to come up with such a process. Okay, you're gonna write PA, PB, PC, and PW given A, PW given B, PW given C, and now I want to find out PW. So what was the thing that I talked about in the beginning of the class? Law of total probability. Okay? Law aslında law kelimesi Türkiye'de bazen law diye okuyanlar var. Hukuk okuduğu halde law diye okuyanlar var. Law diye okuyanlar var. Doğru okunuş şöyleymiş. Law. Law. Yani sondaki W'yu söylemiyoruz. Law. Father-in-law. Law is critical for everybody. Law. Okay? So it's like a law thing. Okay? It's not law. Okay? It's law. Okay? It's not the main point. Okay? How do I write the law of total probability? It's going to be like white given factory A times probability of factory A plus probability of white given factory B times probability of B plus probability of white given factory C times probability of C. So what is probability of white given factory A? 0.3 times probability of A 0.5. 0.5 plus probability of factory white given factory B 0.4 times what is B? 0.3 plus 0.25 times 0.2. 0.25 times 0.2. Okay, then I will find out 0.15 plus 0.12 plus 0.15 0.05, which is going to be equal to 0.32, which is 32%. Probability is 0.32, also 32%. Percent means I'm going to put out of 100, right? 32%, 0.32. Is everybody clear on that, guys? Is everybody clear using this low total probability? Okay, factory A, factory B, factory C. What is the probability of obtaining a white car from a factory A, white car from factory B, white car from factory C? We have to find out the probabilities of choosing a factory, and then probability of obtaining a white car from that company or factory. And then I find out the total law. I used law of total probability in solving this question. Okay. How about this one? Given that an automobile is selected at random and it is white, find the probability that it came from factory B. Can you tell me what is being asked? Please write to chat. What is being asked here? Probability of what given what? Okay, given that an automobile selected at random is white, what is the probability that it came from? Very nice, Enes. Cansu, very nice. IBK, good job. Burhan, exactly. What is given? What is given? I know that it is white, right? I know that it is white. What's the probability that it came from factory B? So I should put the thing that is asked here, that is known here, okay? Before this line, I should say, I should put asked, okay, what's the probability that it came from factory B? Given it is white. Is that clear, guys, how I write these things? Yes? How do I write probability of white given B times probability of B divided by probability of white? This is Bayes' theorem. Right? That's the formulation from Bayes' theorem. Do I know probability of white given B? It is given in the question. White given B is 0.4. 0.4. What is probability of a car coming from company B or factory B is 0.3. 0.3. What's the probability of obtaining a white car? We found it in part A. It is 0.32. 0.32. Okay. So then I'm going to plug in the things that I know. It is 0.4. This is 0.4 times 0.3 divided by 0.32, which is going to be 0.12 divided by 0.32. It's going to be 12 over 32. 32. If I do this, divide by 4, 3, divide by 4, 8. It's going to be 3 over 8. Is this clear, guys? Yes, the value is 375. 37.5%. Okay, are you with me, guys? Is that clear on your side? Easy, right? Until now, it's easy. Now, I want you to work on this question right now. Start recording. How can I say this in sentence? Probability of obtaining a computer from company A is 0.4. Probability of obtaining a computer from company B is 0.3. Probability of obtaining a computer from company C is 0.3. These are given. What are the other things that are given? Probability of, let me ask another person. Melissa, can you tell me probability of, how can I write this? Is late 5% of the time? It's coming from company A and it is late. What is it? Probability of what given what? For this late 5%? Melissa, do you hear me? Okay, Musa, what do you say? What is this like late 5% and it's coming from company A? How can you say that? Probability of, Musa, are you there?
I don't know hocam.
Benimle misiniz, yani niye bilmiyorsunuz mesela acaba? Hani şey mi? Konu mu anlaşılmadı?
Evet.
Onu merak ediyorum.
Hayır hocam ya biraz koptum da dersen. O yüzden oldu
Evet.
kusura bakmayın. Özür dilerim.
Tamam, estağfurullah.
Yoksa konu kolay yani.
Konu kolay, yapacağınızı düşünüyorum. O yüzden hani tek tek gitmeye çalışıyorum. Rahatlıkla yaparsınız inşallah. So probability of being late, if I know that it's coming from company A, is going to be 0.05, 5%. Probability of late, if it is coming from company B, is 0.03. Okay. Probability of late, if it is coming from C, then it's going to be 0.025. Okay. So how did I write this? If it is coming from company A, what's the probability of being late? If it is coming from company B, I know it is coming from company B. What's the probability of it being late? What's the probability of that computer coming late, delivered late, when I know that it's coming from company C? These are all given here, right? 5%, 3%, 2.5%. So what is being asked? Probability of obtaining it, probability of it's coming from company A, and I know that it is late. Okay, this is asked and this is known. How will I write the conditional probability or Bayes' theorem? Probability of A divided by probability of L. Okay. So, do I know probability of L given A? Is it given?
Yes, hocam.
Yes, this one is given. Where is it? It is here. What is this one? Probability of A, and it is given here. Do I know probability of L? I don't know it, right? So I have to come up with the use total law of probability, and it's going to be PL is going to be PL given A times PA plus PL given B times PB plus PL given C times PC. It's going to be equal to 0.05 times 0.4 plus 0.03 times 0.3 plus 0.025 times 0.3. Okay, I multiplied this with this, this with this, this with this. Okay, so in order to find the total probability of a computer being late is going to be equal to this. Okay, And let me write the answer here, 0.0365. Okay, probability of a computer being late is like 3.65%. Okay, so now I know this, and I know this. Now it's time for me to find out this. Arkadaşlar, diğer soruyu quiz olarak yapacağım. Onunla soruyu bitireceğiz. Herkes hazır olsun chat'in başında. En son sorumuzu quiz olarak yapacağız ve o da ayrıca bir in-class exercise olarak karşımıza çıkacak. So probability of L given A times probability of A divided by PL. What is probability of L given A? It is given here 0.05 times probability of A. It is given here 0.4 divided by 0.0365, right? It's given here. Okay, so what is the answer? 0.02 divided by 0.0365. It's like 200 divided by 365, okay? Which is going to be equal to 0. Something close to 0.548. Okay, what is the thing that I'm doing in such questions? I'm finding using the total law of probability. First, I need to write the probabilities like that, okay? I need to write probabilities like that from the question itself. And then I should write Bayes theorem formulation, knowing one of the probabilities. I want to know the other probability. And then I'm going to check which ones do I know, which one I don't know. I know it from the question, this one. I know it from the question, this one. But I know it, I don't know this yet. I need to find it out using total law of probability. It's going to be like the probability of late, obtaining a late computer when it's coming from company A times choosing the probability of company A, and so on. And then we found the probability of a computer coming late being PL, okay? This is the probability of obtaining a computer late. And then finally, we put the questions, we put the values here. This is like 0.05, and this is 0.4 from the question. And this is something we found here, 0.0365. And then finally, I will get this, this division and obtain 0.548, okay? So let's go to the last part of our class today. It's going to be the last example of Bayes' theorem. You may find many examples on the web. You can go to the probability course.com. You can go to our book and find out many examples. You can find out many examples like that. There will be a question. There will be in one of the quizzes coming next. There will be a Bayes theorem related question, inshallah. Okay, so let's get ready for this quiz right now. I want you to type in your solutions, okay, to chat, and the chat will be my grading point here. Okay, so you're gonna write on chat what the result will be like. I'm gonna read the question and tell you, give you time for the solutions. I don't want only the number as a solution, but I want you to show me, I plotted, I did this just as I wrote here, okay? I want you to give me the details of your solution. You can come up with a tree, anything like that, but you can do it with your hand, but you have to put it in words in chat, okay? Here's the question. There are 5 red and 2 green balls in a urine sack, okay, torba bag, okay, a random ball is selected and replaced by a ball of the other color. Okay, I'm selecting a ball. If it is red, I replace it with green. If it is green, I replace it with red. Okay, so replaced by a ball of the other color. Then a second ball is drawn. Okay, what's the probability that the second ball is red? Okay, the second ball is red. What's the probability of that? What's the probability of the first ball being red, given that the second ball was red? Okay, so the first ball, what's the probability of obtaining the first ball being red, given that we know that the second ball was red? Okay, so you have like 3 minutes, and please type it on chat.
Hocam, do we need to write the exact solution or just the way?
The way and like put multiplication kind of things is enough for me, okay? Multiplication is also enough.
Okay hocam.
Just don't send to everyone, just to me, okay? Direct message. Just direct message, please. I don't want you to not only give me the answer, I want you to show me how you found it. Okay, multiplications and descriptions. I don't need the outcome yet, okay? Please, I want you to give me how you found the result. Hari, this is the answer for A, right? Put like, tell me this is A and this is B. Put two answers at the same time, okay? Abdullah Burhan Doğan, please check your calculations. It's not correct. Calculations are not correct. Yes, better. Enis, please give me how you found those answers. I forgot to record the solution, but I hope it's not a problem because it was a part of the quiz, and I will share these notes with you so that you can, if you want, you can go over them. I hope it was a beneficial session, and that's all for today.